Hi, so this video is to introduce how the CD triaxial test, how the CU test, and UU test are running. So for the CD triaxial test, the phase one is to saturate the soil. The reason why we want to saturate the soil is that we don't really want any air in it, because when you apply the pressure, and you really want to apply the excess portal pressure that has been transferred fully into the water. And that's also one of the assumptions of the triaxial test, where you always conduct the test on the saturated soil. So the first step is to increase the soil pressure and back pressure in stages. That means you will firstly increase the back pressure. So let's say 490 kilopascal. Once you have done it, the soil sample will be saturated with soil. And then because if you just apply the pressure inside it, the soil pressure will kind of like expand outside. So to constrain the soil or to cancel out pressure, you will apply a soil pressure outside of the soil to cancel out the stress, and it will be just a little bit greater than the back pressure. All right. And you just leave the specimen to saturate. So after that, you will have to perform a bead check. The reason why you have to perform a bead check is that it helps you to identify whether all the air has been expelled out of the soil. So in this way, you will close the back pressure. Close the back pressure valve. This thing. And it will increase the sigma 3 by a small amount of 10 kilopascal here, and it will increase 10 kilopascal. So from our knowledge of the geomechanics, the soil will correspondingly respond to this increase of the cell pressure. So if you gauge the pore water pressure here, it will increase by 10 kilopascal, which from the first slide, 490 kilopascal to 500 kilopascal. And then if the B is greater than 0.95, you're free to move to the next phase. Just note that now the back pressure is 490 kilopascal. So when you enter the next phase, you will have to increase 10 kilopascal, because when you open the valve, you will really want to see that, okay, the pressure are balanced, so that the soil will not be compressed before any consolidation is actually conducted. Okay, then you increase 10 kilopascal to cancel out edge, and you open the valve, and then you will increase the cell pressure to 700 kilopascal, and it will because the back pressure here is 500 kilopascal, and this is the 700 kilopascal. It will have a 200 kilopascal deficit of it, so that this will create 200 kilopascal excess portal pressure. That will be the excess portal pressure you will have to consolidate, or you will have to dissipate during the consolidation phase. And it will just monitor change in a volume from back pressure pump. So when it consolidates, we'll generally have a volumetric change, and it will be like, let's say, -3 milliliter. Just note that when you plug that into calculation, you will have to transfer that delta V into I don't know, maybe it's +3, because you will actually have a change in that. It will cancel out that change. We'll see that after it. And then to perform the sharing, you will have to open the valve again, and you just apply the pressure very slowly, and now your sigma 3 is kept a constant definitely. So you will apply the P equals to 1,600 Newton by it. You will just expand. So there's nothing too much, and when it fails, it will share, bulge, or fail, and drain friction angle can be obtained from test, because we'll have like a theta here. You can just calculate the friction angle, or you can plot that thing onto a tall sigma plane, I think. And it'll be extra stages or tests are not required to find drain friction angle, and that's not saying anything. Yeah, and for the CU test, that's probably the same for the saturation phase and consolidation phase for the CD test. But for shearing, you will, so after it consolidated, we'll have to close it, and then you apply the load. When you apply the load, this pore pressure will definitely go up. And just saying that this pore pressure is to gauge the change in the pore pressure is to gauge changing the how much pressure that has been transferred to soil. So it gauges the soil pressure. No, I think that's the, yeah, it gauges how much pressure that has been transferred to soil. Because the pore pressure in it is consists of the excess pore pressure and the back pressure, where we don't really care about back pressure here, so there will be excess pore pressure gauging, right? Yeah, right. And the specimen will actually share a lens, and that's yeah. Just to note that CU test will have different calculation. We'll have the equal radius for the total and the effective stress. And for the UU test, you'll still firstly saturate the soil and then keep the soil pressure constant with no drainage allowed. You will apply pressure, and then you will measure displacement actual load and increase the actual load through the constant displacement. The soil sample will share. So generally in this case, you will have something like that. In this case, I think. Yeah, let's just cancel each other.